Welcome and thank you for joining us today. I hope you're doing well. Let's begin with a quick introduction. Could you please tell me about yourself? This is usually the first question in almost every interview. A good way to answer is to briefly introduce yourself and then focus mainly on your professional experience.
Before we move to the technical questions, I'd like you to rate yourself from 1 to 5 in Java, Spring Boot, and microservices, where 5 is the highest. Please explain your ratings briefly.
When answering this question, always be honest with your ratings. Explain your rating with practical experience.
True or false? Composition is generally preferred over inheritance for greater flexibility and maintainability in complex systems. Why?
True. Composition is generally preferred because it promotes loose coupling, better flexibility, easier maintenance, and greater code reuse. Instead of inheriting behavior from a parent class, objects are composed of smaller reusable components. This makes the system easier to extend and modify without affecting existing functionality.
Excellent. Explain an advanced strategy for starting a service while ensuring thread safety and minimal performance overhead.
I would use the initialization on demand holder idiom or double checked locking with a volatile instance. Both approaches provide thread safe lazy initialization while minimizing synchronization overhead. The object is created only once when required, and after initialization, no unnecessary synchronization impacts performance.
How would you ensure running threads always see a consistent configuration when configuration is refreshed?
I would use immutable configuration objects. Instead of modifying the existing configuration, I would create a new immutable configuration object and replace the old one atomically. Existing threads continue using the previous configuration safely, while all new requests automatically use the updated configuration without any inconsistency.
You are designing a REST API for a high traffic financial application where certain endpoints must prevent duplicate transactions. How would you implement item potency?
I would require clients to send an item potency key with every transaction request. The key would be stored in a shared database or Redis with a unique constraint. When a duplicate request with the same key arrives, I would return the previously stored response instead of processing the transaction again. This guarantees that duplicate financial transactions are prevented.
How would you handle race conditions when multiple requests with the same item potency key arrive almost simultaneously? I would use atomic database operations with a unique constraint or a distributed locking mechanism. The first request creates the item potency record with a processing status. Any concurrent request detects the existing record and waits or returns the existing response.
When migrating a monolithic Java application to microservices, how would you maintain data consistency across distributed services?
I would avoid distributed transactions like two-phase commit because they reduce scalability and increase coupling. Instead, I would use the saga pattern, transactional outbox pattern, event driven architecture, and idempotent consumers to achieve eventual consistency across distributed services.
How would you handle failure scenarios when a downstream service in a saga fails?
For temporary failures, I would implement retry with exponential backoff. If retries are exhausted, I would move the event to a dead letter queue, DLQ, for later investigation. For business failures, I would execute compensating transactions, such as refunding a payment or canceling an order. Compensation operations should always be idempotent.
You are optimizing a Spring Boot application that caches millions of user sessions. Which Java collection would you choose and why?
I would use concurrent hash map because it provides thread safe, high performance access for concurrent reads and writes. I would configure session expiration and cleanup to optimize memory usage. For distributed deployments, I would use Redis or Caffeine for scalability and efficient memory management.